set the context. In these particular sessions, we are talking about various algorithms. Like in the earlier session, we have seen some usage of the KNN, and then we have seen naive Bayes, and thereafter, in the earlier session, we have seen decision trees, if you remember, guys. These decision trees, of course, everybody knows is a kind of approach where we can mention some decision nodes, okay, all these kind of the conventions. But the important point here is the background of this tree logic, how these decisions are taking place, like entropy we have seen with example, and thereafter we have seen some entropy can be referred as information gain, and then we have seen some this thing actually chi-square, because these things helps us to decide which is the best condition so as to split the nodes, because the decision tree is logically dividing the appropriate thing, yes or no kind of thing, and of course these decision trees are very much helping us in the regression model also. Now, in the same genre, we were talking about the support vector machine, which is famous and which is having a peculiar property that I am going to reveal compared with other algorithms. Okay, so basically this can be imagined. Okay, because SVM model, it is available in support vector classifier, support vector regression. So here let us stick to the support vector classifier. So because basically it is belonging to the supervised and classification model. Of course, it is also permitting us to implement our task with regression based also. Now, a support vector machine, okay, this can be imagined, okay, like we can specify these thing as a surface model, okay, as a surface. Suppose in the dimensional space, I'll give you some diagrams on that. In the dimensional space, the surface that defines, just it is going to mention a boundary. Okay, because friends, in the classification, what we need to do is we have to observe which class it is belongs to. Maybe yes or no, true or false, or whichever the things defines a boundary between various points. Okay, whatever the, because at the outset, just we are going to talk in terms of the numbers and points only. Okay, so which represents, okay, basically which represents a kind of the examples, okay, in multi-dimensional space, okay, examples of some kind of the multi-dimensional space. So let me pull some image about what I'm talking. And because guys, this particular support vector machine is equipped with various things like kernel trees, linear and non-linear models, all these kind of the aspects. Okay, so these dimensional spaces are dependent on or according to the feature values, because every data item we are having some set of the features, and those kind of the features can be observed. Let me pull some image for us guys to clear understand. I have picked up something for us. So, and moreover, this SVM kind of the approach is very much helpful even the multi-dimensional models also. Multi-dimensional in the sense, in general, we will be seeing about X dimension and Y dimension, and there is a two-dimensional space. Okay, observation like regression, how we do. But whereas in the real-time scenarios, we may not get the appropriate dimensions specifically to one or two or three. Maybe more dimensions would be there. So for those kind of the approaches, you can follow up this. You can support this kind of thing. Now have a look on this guy. This is one kind of the class. This is another class. Label set of labels. As I said, this is a kind of the surface. And with respect to this surface, we need to establish a kind of the margin. On top of these particular margins, and here the idea is that the margin should be large, okay, the margin, because this particular margin is something like which is separating the appropriate classes. Now, in that separation, what we can see is the best possible separation. Okay, so among these particular entries, how we are going to separate all these kind of the aspects, that is the important thing. And as a name, what exactly this support vector? Because if I'm talking about the naive Bayes, that is backed by Bayes theorem. If I'm talking about the k nearest neighborhood, that is based on the kind of distance measures, distance calculations. In terms of the decision tree, we're having a tree structure. What exactly is support vector? Support vector is nothing but on top of these particular plane, our aim is to establish a kind of the margin. And in this particular margin, so whichever the place, whichever the points I'm having, so as to classify the things in a better way, is a support vector. Okay. So the goal of the SVM is to create a flat boundary, just a kind of the boundary called hyperplane. Just you can see here, friends. We can see this hyperplane kind of thing, which leads to fairly homogeneous partitions of the data on either side. So here, one kind of the partition I'm having, and this partition must be homogeneous in same kind of the values. If you observe the logically, the color combination, and this is another partition. Okay, this is also containing the homogeneous kind of the data. So likewise, friends, here the aim is the support vector mission aim is uh, establishing, okay, create a flat boundary called the hyperplane, and which leads to the fairly homogeneous partition kind of the aspect. Now, maybe 2 points can come into the picture. Guys, in case of the linear regression, what we'll do in a simplest way, okay, so establishing a kind of the relationship between two variables. Suppose just I'm having beta naught plus beta 1x where y equal to. This is the basis equation. Just we are making use of the kind of the relation between these two values, okay, dependent and as well as the independent. Now, in case of the KNN, so just based on the distance, okay, we are going to compute the measures of the classification. So SVM can be analyzed in this reference is a combination of the logical I'm talking. So KNN plus as well as the regression. Many peculiarities are there, friends. If I'm talking about the support vector machine, um, rather than logic, we need to observe some kind of the concept. Because in all the other kind of the things, as I said, so far what we have covered, those are all having some sort of mathematical and all the approaches to solidly define the logic. But here the support vector machine, most of the time we need to imagine these kind of the things, like how I am making use of the planes and how these particular classification happens. And suppose if I am having multiple dimensions, then how do I achieve these kind of multiple dimensions into two dimensions? Because at the end of the day, definitely we need to give the outcome or plot the graphs between these two dimensions only, majority of the times. So obviously what we'll do is whatever the data I'm having, the data should be turned into a linear model. That non-linear data, whatever I'm having, that should be converted into the linear model. So you may ask me this question, then where do we use this SVM? Because the approach is just we are talking about the applications, maybe in your projects or something, there is a chance of referencing these kind of things, especially friends in the facial recognition. Okay, so the facial expression recognition. Okay, just I can use the support vector machine, and of course the speech recognition. Okay, so because guys, in terms of verification of the speech or audio or these kind of things, just to separate whether this audio is original or whether this guy, whoever talking is matching with the audio clip, all those kind of things, you can go ahead with the SVM. And moreover, handwritten digit, because in the ancient kind of thing, we don't have any the printed media. So sometimes there is a possibility of identifying our culture and all those things, and there we need to decrypt the appropriate symbol, or at least we need to observe that symbol, what exactly that symbol is. So for that purpose, also handwritten digit recognition also to those kind of the applications, I can apply the SVM. And most importantly, guys, the text classification. Okay. So this particular text classification is also one of the important application area where you can venture related to our support vector machine specification. Okay. And why do I use that? Because first we need to observe which are all the applications, and then why I need to go with the support vector machine, and I will ask you some kind of the classifiers. Okay, I'll give some kind because I'm talking about facial expression, speech recognition, handwritten digit, text classification. In that particular case, the crucial part is maximizing the margin. Okay, so this diagram clearly helps us. How do I specify the specification of the hyperplane? And my basic aim is I need to increase this margin because multiple classes are there and there is a separator, and this particular separator should be strong in such a way that with the help of the support vectors on top of this particular hyperplane, we are going to get the outcome. So that outcome is maximizing the margin and separate the appropriate partitions, and each partitions are containing the homogeneous kind of the data item. Okay, so this is the idea. And here are all the advantages of the support vector machine. Because after identification of the applications, now we need to observe, okay, why do I need this particular SVM? Because other algorithms are also there. Why should I go with the SVM? Because believe me, guys, before closing of the session, definitely you can observe what is the specialty of this SVM compared with other algorithms. Okay, and majorly, this feature is common for navy and all these things. If features are quite large, okay, if features are quite large, in that particular case, one can prefer the support vector machine. This comes handy, friends, whenever your data, okay, the data both in case of the linear and as well as the non-linear kind of the relationships. I'll give you what is the difference between linear and non-linear. So if I am referencing these kind of things, especially if you are referencing the linear kind of the model. So what do you mean by linear is if there are certain classes, friends, class 1, class 2, class 3 like that. If I am able to easily separate the data with a hyperplane, drawing a straight line. Now if I am taking a plane and I'm having some set of the data items like this and some other data items. Now, if you are drawing a line, so there is a clear separation. So this is one class and this is another class. And this kind of the data items belongs to the linear model or linear relationships. Okay, whichever the data I'm having, and if I am able to draw a line, and this particular liner is going to separate the appropriate classes. Okay, this is a linear relationship. Now you observe this guys. In this particular case, I'm having certain parties like this, some portion of the data like this, and I'm having some certain surrounded data. So is there any possibility of drawing any line or something, friends? I cannot separate these things with a single line. Okay, I need to do some analysis and I have to use some trick so as to separate. This is what we call the non-linear relationship. Because linearity, clearly we have seen there is a clear separation among the data items. Whereas in case of the non-linear relationship, it is something like it's not clear. It is not possible to separate those things with the lines of item. Okay. So of course, these things we can achieve with the support of the catalytic. That is the most important and striking feature of the SPM. Okay. So even high-end kind of the projects also. If you are having more non-linear kind of the relationships, then the ultimate algorithm which we can bank on is the support vector machine. So in non-linear relationship, but you may ask this thing. In case of the linear, we are pretty clear that there is a kind of this operation. But whereas in case of non-linear relationship, okay, there comes handy the concept of you can customize with the kernel. Okay, so I'll be talking about this thing in a while, guys. But without kernel trick, there is no SVM because the reason is, moreover, support vector machine is also trying to separate classes, different classes, as that of KNN, naive Bayes, and all these things. But the specialty of this algorithm is kernel trick. Hmm. And there are, of course, some pitfalls are there, but I don't want to reveal those pitfalls now. Rather, what I'm doing is I want to specify those drawbacks at the end of the session. So which kills the interest of the support vector definitely. So now let us enter into this genre, how support vector machine classifier works. Okay, because so far what we have seen is what exactly SVM, maximum separation on the hyperplane, and our aim is to maximize the margin. And then, which are all the support vectors? Support vectors are nothing but the entry points, which are all available on these kind of the margins. And here, the support vector machine supports both the linear and as well as the non-linear relationships. In case of the non-linear relationship, we need to make use of the convention that the kernel tricks. Okay, so we can make use of that thing. So how this classifier works basically? Okay, so you observe that there's some kind of steps I am proposing here. Just it is plotting each data item, whatever we are giving each data item as a point in, so just it treats that as a point in n-dimensional space because this algorithm also known as dimensional algorithm or hyperplane kind of algorithm. So because the way it works related to the corresponding data items is identifying as a plane and it is treating that as a surface and it is trying to maximize the margin on top of the hyperplane. Now the next task is after plotting these kind of the data items, it has to identify okay the hyperplane. Okay, hyperplane already have shown you in the diagram, guys. Just if you see, the hyperplane is something like that is a space actually. Is a dimensional space, and this thing is going to establish in the n-dimensional space after plotting all these kind of the diagrams or after plotting all these points from the data set. The next point is just it is identify the hyperplane which differentiate. This is the important thing differentiate the class correctly. That is the aim. No? So because every classifier say aim is to get the correctness in the corresponding specification, and of course aim is maximum margin is highly recommended because why we are referring these things is that if the margin is high, guys, automatically the separation is more, and there is a chance of getting these particular points in a most homogeneous way. So suppose if I'm considering this partition one, partition two, maybe some other partition might be there, and partition four. So if the separation of these things is high, then we can able to maintain the convention of the homogeneous kind of the property. Now, the one more important thing is I'm explaining here is the types of the SVM classifiers because there is a chance of getting the linear models and as well as the non-linear models, and we're having two types, friends. Okay, so just we're having the two types of classifiers, as I said earlier. But again, why I'm saying this thing is I'll give you some images now and those particular images we have to identify which is the best line. Okay, so I have to classify the things, and here I may have the linear classifier As said earlier, linear classifier is something like which predicts a straight line or plane. And the primary focus is, of course, while drawing the plane, is on maximizing the distance from hyperplane to the nearest data points on either side. Okay, so just I'm taking the points, point one, two, three, like this. And here I'm having some more things. This is drawn, and there is a hyperplane, just it has to observe, and it should establish a kind of the margin between these two, and it is going to draw the line, okay, separation, and here also it is going to draw the line. And based on these support vectors, okay, so maximization of this particular margin, which automatically gives the separation of the appropriate homogeneous classes. That is the ultimate. Without this hyperplane or margin explanation, there is no chance of understanding the support vector machine, guys. Okay, this is the first method. And the second one, because why we are studying the support vector machine is obviously your support vector machine with the help of the kernel trick, it should able to establish a kind of the nonlinear relationship into the linear model. So nonlinear classifier by applying the kernel tricks for maximum margin hyperplane, all these kind of the things you can perform. So let me pull some kind of the diagram for us guys, where to better understand the support vector machine kind of thing. I'm just you can mention. So how do we uh, specify? Suppose I'm asking you this question. Out of these things, what is the best boundary? Now let me yes. Okay, let me enlarge. Focus on the image, guys. Just here, I'm having two classes actually. This is circle class and this is a triangle class. And I'm having three different. I can say these are all the hyperplane kind of thing. Three different lines. And first line, second line, and third line. Now, what is the best line, friends? Here,
So the middle one is the best fit,
best
I
one.
think.
Okay, the middle one means
The
first
first,
line. Okay,
because the
why it is
margin is
so?
maximum.
Exactly, exactly. Margin is high. That is our aim, friends. Actually. Because the margin is high, it's specification like guys. Those second and third lines also they are correct only. They nothing. They have not classified anything wrong. But still, we are with first line SVM. In fact, the algorithm SVM is with this particular first line only. It prefers the first separator only. Reason is the ultimate goal of this separation is maximizing the things. Now, let me ask you this thing. Suppose I am asking you another example. So be cautious, guys, because it is somewhat complex compared with the first one. And here, some more options are there. What is the best line? Because here I am having one, two, three straight line kind of things, and there is a fourth line and as well as the fifth line. Maybe because in terms of SPM, it is going to draw different kinds of the margins and different kinds of the separators, and at times without any confusion, it has to take care about the corresponding margins and all the other kind of the hyperplane aspects. Now, do you think one or five? Because I doubt either one or five. Which one is better, guys? Actually.
If you will take the one, then you can see
Mm.
like on both the side the margins will be uniformly distributed. Like hyperplane
Mm.
will be better. But if you see
Mm.
the fifth one on the left side, you will see there is large margin. If you will take the half of it, so half more than half
Uh,
of it is present on the left of the side,
correct,
and
correct,
the right side it
exactly.
is not exactly half. So that's why.
Not exactly. Exactly. So mean to say that fifth one is something near to this class friends actually. This particular portion, whereas it is far from this kind of thing. Our aim is it should not deviate actually. See the separator should treat the appropriate lines equally, and it has to maximize and homogeneous property retains. Again, in that case, answer is again one only. Na? Again, one we have to go, because though five I am claiming, but still ultimately this particular first line is the best possible way of picking up of the best margin. No, story not ends here. And one more thing I am going to ask you. If you are making use of this convention, maybe it is a bit easy compared with the second one. The third possible thing I am asking you, just to have a look on this, guys. How do you observe this kind of the boundary? How do I manage the conventions?
This one is bit tricky, but yeah.
uh,
So
which one? Uh,
like third one, I will say the third one is the correct line. But yeah, in SVM we say like we can have something called as like some chances of misclassification so that the model will not get
oh,
out of it.
mm, exactly. Exactly. But see, our ultimate goal is to classify maximum number of data points with high accuracy. Okay. So when it comes to algorithms, maybe if you are leaving SVM and going ahead to naive Bayes and you are applying the logistic regression, later you are applying the decision tree. Ultimately, if your manager is asking you, you have to decide, yeah, and you should, you should suggest me one algorithm, and I don't want to have all those analogies, and we don't have any time also. We need to suggest to the client. That is the discussion. In that particular case, ultimately, guys, that is not the, SPM understanding, decision tree understanding, or random forest understanding. It is the understanding that whichever the line or whichever the accuracy is better, okay, whichever the algorithm is giving you the best outcome in terms of best classification, we can vote for that only. In that particular case, friends, if I am managing the specification of 1 minute, yes, okay. If you are managing the spaces of these one, two, and three kind of the lines, as you said correctly, because in terms of this third thing, there is no misclassification actually. Margin high and maintenance of those particular points, that is ultimately the required thing. But our understanding is like this, guys. So if any, suppose if I'm selecting the maximum margin, maybe two, but there are these two things are misclassified actually. Okay. And at times, if there is a comparison of misclassification and as well as correct classification versus maximum margin, maximum margin. Now you observe guys here. Maximum margin is one of the property where to decide how many number of in the partitions or in the separations, most homogeneous in the sense best classification. So ultimately, we have to vote for not the maximum margin. At this point, we should go ahead with the third line only, third hyperplane only, third separator only. Reason is leave that maximum property here, because if you encourage the maximum, though it is the second line is maximum, friends, but there is a misclassification actually. Okay, there is a misclassification and there is a less accuracy. So ultimately, your third line is the best fit line where you can classify these two set of the classes into homogeneous partitions. Okay, so this is how you can manage the things in terms of understanding how do I separate these things. One more option I am giving you. I don't want to leave you guys. So just I want to give one more option to you. So, like, how do you refer whether which one is the best classifier? Okay, which line is, of course, giving the best thing. Just think through. No hurry, nothing. Because multiple points you need to consider here, guys. So let us analyze. First line, it seems though no misclassifications. We can shortlist that. And second line also, if I'm taking, of course, class one is good for us. Class one is not having any impure. It is pure. Same kind of data items I'm having. But in class two, I'm having the mixed combination. There are two misclassifications actually. There are two misclassifications and all others are good. And coming to the class, if I'm taking the second line, somehow it is managing the things in a different way. Okay, like it is not near to. It is very much near to the class two, and it is bit near to class one. And coming to this line three, it is very near to both the classes. Okay, so the analysis here is second and third margin wise also we are not happy. Okay, but of course at least in the first one, if you observe, guys, and one thing, I'm not asking you to exactly class at this moment. Maybe while running fourth time or fifth time after pre-processing, I may get this kind of three approaches. In this particular three approach, SVM has to select one approach, no? For the modification. Even in our life also, we are not going to get the optimization at a time. Okay, what we need to do, out of all possible options which we are having, we need to select those particular three options. Out of those three, we have to select the best one. Now you can give the answer, guys. Now hope I'm clear about this. Which one? Obviously, line one, because it is at least having the big margin. Okay, and of course, which is equally maintaining equal distance among these kind of the things. But the problem comes whenever there is a concept of, like, as said earlier, where if I am making use of my non-linear kind of the classification. Okay, so if I am making use of this kind of the separation, it is if you refer this diagram, guys, when I was talking about that non-linear, I did mention that in non-linear we may not get the approach of the straight lines or hyperplanes or maximum margins or something like that, because this kind of thing is a non-linear relationship. Okay, because there is no other option. If I am taking this diagram again, let me draw this here only, and let me try. Is there any possibility of a line drawing? Suppose if I draw a line like this or like this, or else this one, this one, this one. So line one, line two, line three, line four, and line five. None of the lines satisfy the either of the criteria, margin criteria and as well as the best classification criteria, because the data itself is very scattered. Okay, in the real time scenarios, guys, you pretty know that, like, the data is in all the forms. We are not getting the data in the clean and neat formatted. No, so we will be getting the data in all the shapes and all the kind of thing, and we don't know which dimension to keep, and lot more null values, and you should be spending your entire life of this thing in pre-processing of the data. At least as a machine learning engineer, we are having the flexibility of, okay, getting the a reasonable pre-processed data, and then thereafter we can apply that maximum scalar or some kind of the normalizations, standardization techniques we can use. That flexibility is there. But if you consider the data engineer and he has to see all the possibilities like where do I, how do I handle this approach of empty values or null values, and how do I manage this encoding, all these kind of the conventions. So data comes in all the ways, but it is the responsibility of machine learning engineer or data engineer so as to segregate and maintain the pre-processing of the data. So the most important zone, so we could able to see that if it is possible to separate the data, that's what I picked up multiple examples. So that now as a practitioner, you can have a look of how these separations are happening. Whereas at times the data is like this, then in what way we are going to perform the activities. Now the point of kernel tricks coming to the picture. Okay. So what exactly is kernel trick, and what do you mean by the kernel function? Okay, because guys, these kernel functions are real approach in the programmatical aspects of machine learning algorithms. Let me introduce that. What is a kernel function? And thereafter, if you understand this particular thing, and with various kernel functions, what we can do, all these things I will be discussing. A kernel function provides a kernel trick. What do you mean by this trick? Generally, in our school days, just will play the tricks to escape from the homework and all these other options. Okay, I got headache or frequent sneezing or something like that will tell. Even SPM also, so as to handle that n-dimensional data into the two-dimensional format, it is applying the kernel trick. So what exactly this thing is? A non-linear, just now we have seen. Okay, so non-linear in the sense this kind of the diagram, whatever I'm showing here, this particular diagram is a non-linear kind of diagram. So because there is no separate line or margin, so as to maximum separate the classifiers. Okay, a non-linear relationship, whatever I'm talking about, may be converted to, okay, na friends, maybe converted to appear, maybe converted to appear linear by using the concept called some kind of the transformations, by using some set of the transformations. Okay, transformations in machine learning, especially in Spark, we're having some kind of the transformations, and this is not that kind of the transformation. These are all mathematical transformations. Now to explain with some kind of the algorithm or example, so just let me pull that diagram, guys, where I'm having some longitude kind of the data. So where we are going to get in all the fashions. Now you observe here so that you can easily have the understanding of your kernel. So what we are saying here is, friends, there is a kind of recording all the sensor data like longitude and latitude of a particular space. And if you see, this is a circle kind of thing, which is non-linear. Is a non-linear. Now, we were talking about the kernel trick. What do you mean by kernel trick? Kernel trick, a non-linear relationship may be converted into the, okay, may be converted to appropriate appear linear. Okay, it should be appeared as a linear by using the kind of the transformation. So these kind of the transformations are known as the kernel trick, and some of the transformations I will give in the literature. We're having many transformations, but a radial basis function, polynomial, certain aspects are there, and of course, in our support vector machine implementation also, you have to select the kind of the kernel. Okay. Now, if you refer this particular kernel trick or transformations, what it does is it is handling the appropriate scatter of the data rather than in non-linear. Now you can feel that there is a linear kind of thing with the kernel trick. So there is a separator. Okay, may not be the maximum separator, but at least here we are getting all the homogeneous classes at one side and another homogeneous classes in another side. Now, this itself is a big relief for us, friends, because in the earlier diagram, if you see this diagram, how do we separate these things, guys? Because this is a The entire second class, that circles class is surrounded by this class one. And to understand, at least mathematically, or to analyze this particular kind of the data, we have to separate that particular data and follow up the activities. So for that, we need to have this kernel trick approach. Okay. Now, in terms of support vector mission, if I am talking, there are two options, guys. Whether you can go with the linear, maybe you can go with the non-linear. Now, tell me one thing. Suppose if I'm having a two-dimensional data, that means the data with the linear relationship. Suppose, guys, if I'm opting non-linear type on 2D data, what is going to happen? Okay, so that means I'm trying to say that your data is simple. You are applying the heavy uh, heavy tricks on that data. Misleading or not? On the other round, we have seen actually in terms of underfit condition, data is complex. See, friends, data is complex, but we are electing some simple algo, which didn't work because simple algorithm is not trying to understand the complex aspects of the data. Okay, because the data is containing many relationships and it is trying to say something, but we are overlooking that algorithm and we are not interested to understand what exactly it is trying to say in the context of the data and all these things. But we applied the simple algorithm, which leads to the underfit condition. But here the approach is on the other way around. Like data is simple, but we are going to perform some heavy tricks on the data, which is definitely misfires, friends. That means if you are clear about your data, maybe that is linear, you need not try about the non-linearity, guys. Okay, make sure that if your data is 2D and if you are enjoying the benefits of the linear relationship, go ahead. Okay, SPM is absolutely fine, and of course, to emphasize that we have seen some 4 or 5 different cases like this. Yeah, definitely the linear. This is also this one and this one. But your linear is not going to work in this approach. Okay, in that case, you need to go with the non-linear. Okay, hope I'm clear. If you are referencing the non-linear, this non-linear is something like I don't have any direct approach, so I have to elect a trick, and this trick is known as a kernel trick. What do you mean by this kernel trick? Kernel trick already we have seen like a non-linear relationship with the support of some kind of the transformations. I can convert that. At least I can make that appearance. Okay. So in terms of the linear. Now, how many such kind of the types are there? Because if you are making use of the kernels, ultimately, friends, there is no distinction like linear, non-linear kind of thing in terms of mathematical models. Only it is the user or it is the developer need to take a call on the linear and non-linear fashion. Okay. Now see, this is a linear kernel where I am having certain set of the classes. Just where mathematically we are applying some kind of the product of that. But whereas the other way, just I'm having some other kind of the tricks. Let me post those things here. Okay, so because there are some 5 around functions are there in the study of this SVM. Coming to the second one, the polynomial kind of the aspects. Okay, where there are certain features and I want to apply. Okay, if you observe guys this thing, actually polynomial regression, I have given some kind of the case study on that. Because if you are making use of the linear kind of thing, there is only relationship between y and x. And multi-linear means y, x1, x2 we are having. But some other cases are also there, friends. Maybe we are applying some jobs and in that particular case, we are claiming the sal as 30 to 35% hike. on the given pay. But that company, with our experience, with our qualification members, it can give only 25% hike, whatever we are claiming. Now, the challenge here is we don't want to lose this guy with higher potential and as well as the qualification. But how do I approve that? How do I know that? Okay, in that case, just you can emphasize on SAL, okay, and you can dig through the polynomial regression. So, very best use case we are having, guys, with that. So this polynomial regression, what it does is now the equation is pretty simple. Your y remains normal, beta naught, beta 1 x, beta 2 x square, beta 3 x cube. C. The emphasis on only one feature, guys. Okay, that is the beauty of polynomial regression. In case of normal thing, we are having in terms of simple, it is pretty simple, simple linear. Whereas in case of multilinear, I am having beta naught, beta 1 x1, beta 2 x2 is a kind of thing. But whereas just now we have seen this polynomial, okay, what it does is just it is making use of these kind of the convention, beta 1 x square, beta 2, sorry, x power 1 x square, beta 3 x cube. Only one value we are emphasizing so as to see the possibility of these kind of use cases. Actually, I have given one use case like the person is claiming for higher pay, and we need to confirm with the studies and with a lot more thing. But as per our standards or company policies, we can offer only 25%. But we don't want to lose them. But by simply approving and by simply getting the evidence of his expertise and all these things, we badly need that guy. Suppose that. So in that case, polynomial and the advantage, friends, here why I like to practice these machine learning and all these things is there is always a connect actually. Even I am talking about the regression, I should have a reference of the classification. If I'm talking about the classification, I'm having the reference of regression. And the connect is math, friends. Actually, the connection is the statistical functionality. So your polynomial kernel, if you are making use of some homogeneous kind of the data items, then you can apply this polynomial kernel trick. Whereas your data is non-homogeneous, in that case, you can go ahead with the second category of this polynomial and most frequently used sigmoid or RBF. Sigmoid friends, actually, if you are referencing the deep learning kind of the technique, there we are having TANH, sigmoid, ReLU, rectified linear algebra, all these kind of the functionalities we are using. So in deep learning, practically the images or audio or video kind of the captioning, or especially the non-linear or unstructured kind of the data processing is more in the deep learning. So that we are electing all these sigmoid, TANH, and all these functionalities. But here, the slight non-linear categories we are seeing here now is this kind of the data, or else I'm having this portion of the data. Then I should go ahead with either RBF or sigmoid kind of thing. So the simple trick here is in the implementation of your support vector machine, if it is linear, don't worry. It takes about the separation of the margins. Maximum margin is our approach, maximum margin, and getting the homogeneous kind of the portion. Whereas if your SPM handles the non-linear kind of the data, within that you need to select whether I should go with the polynomial or else radial basis function, or else one more we have seen the latest this sigmoid actually. Sigma, yeah, sigmoid. So based on these kind of the things, okay, I can able to empower my kernel trick and I can come up with observation of non-linear into the linear fashion. So I escaped one kind of the topic that time. Actually, we are in the last 5 minutes. So what I want to give you is what is the pitfall or downfall of this SPM? First, we have seen all the application areas, facial recognition, and some kind of the handwritten digits observation, and even is sound recognition or speech recognition, which are high-end applications, right? So your SPM should be very approachable and very stringent at the same time. It is involved in the complexity of handling the n-dimensional data. So why SVM is differ with other algorithms is due to the kernel trick, we can pacify those non-linear relationships into the linear model. That is the main key factor in the SVM. But of course, as humans, how we are having weakness, these algorithms are also settling down with some kind of the weakness. Of course, the main challenge of every developer is how to handle the complexity. So, of course, your SVM is high algorithmic complexity. Okay, this is a pretty complex algorithm, and moreover, to handle the complexity, what is the ultimate victim friends memory? So that obviously it receives extensive memory requirements. Okay, we have to specify the appropriate memory requirements. And moreover, guys, when it comes to explainability, the best possible way is decision tree algorithm. Or even in case of the random forest also, you can explain uh, the things as a ChatGPT kind of thing. Whereas if I'm making use of the SPM, your explainability is a bit less, guys. So just have a look on this. Okay, so you need to prepare yourself. How do you leverage that particular understanding or all these things? And most importantly, choice of kernel. As I said earlier, it doesn't mean that if I'm left and right selecting the non-linear kernels for the sake of linear also, it leads to unnecessary complexities. Okay, so that means to be precise, a wrong choice kind of the kernels leads to less prediction, of course, or else accuracy also badly affected. Okay. So this is how you observe. The approach we following is, guys, rather than taking some example explaining, I'm trying to give you the mathematical and the formulation of those kind of things. So which really helps us to come up with whenever I'm talking about face recognition or speech recognition or something like handwritten kind of thing. Of course, you can go ahead and make use of the SVM. And moreover, this SVM is good for this thing actually. Uh, I would say the text-based kind of thing. And one more thing, as a kind of the closing remark, one minute. Yes, I implemented all the algorithms. Okay, like if you are making use of the predictions on top of this classification, let me share these fingers with you so that you can have a look on the identification, how these particular algorithms are having high impact. You see, guys, here there is a classification and regression kind of thing, and these are all normal pre-processing kind of aspects, all pre-processing, all a typical Python kind of thing, some kind of observation. Logistic is giving 81.01 percentage accuracy here, our logistic. Okay, and whereas K-neighbor, surprisingly, it is giving 92.53. Okay, K-nearest. Whereas if you are referencing support vector at this moment, friends, actually, because as I am talking about SPM here, so it is only given 75 support vector method. And naive Bayes, of course, reasonably 84.42. And surprisingly, your decision tree and as well as the random forest reach it to 100%. Okay, obviously, you can say logistic is 87. KNN also done well. That's what I'm saying because it is not dependent on um, it is not dependent on always the non-linear linear nature of the algorithm or the capacity of the algorithm. It all depends on the data frames actually. Because in this particular example, our SVM is scoring very less actually compared with any algorithm in this example. Maybe logistic or maybe KNN. KNN is excellent after this decision tree and your random forest, KNN is really doing good in this example. Okay, so that is what I'm saying. It's there is no hard rule, guys, because it is all in terms of machine learning and deep learning kind of the applications. It is all trick. We have to follow and we need to maintain some sort of all these kind of the approaches while performing the activity of understanding of these kind of algorithms. Okay, it comes from various logics, like how do I refer the convention and all these kind of the approaches. Other than that, nothing. There is no magic at all. Okay, let me give the key takeaways without any wait, so that we can wind up the session. So the key takeaways, just I introduced the SVM kind of aspect with respect to these things. The very first thing is, of course, SVM. Some terminology you need to remember, guys. The margin, hyperplane, and then support vectors. Okay, all these kind of things we have seen. Then application areas, where do I elect these kind of things? And speech recognition and some kind of the handwritten handwritten symbols or digits for all those things. And advantages, pros wise, advantages, friends, number of features more also no problem. It handles. And moreover, it handles both linear and non-linear data. That is the main advantage there. And of course, cons, drawbacks, memory expensive, okay, because it is high memory requirements. And moreover, explainability is less. Scale. That is, of course, pitfall. We need to agree that. And unnecessary, don't use non-linear in terms of the linear relationship data model. Linear itself means you can go ahead with the linear approach only. And then the most important thing is the kernel tree. Okay, this is how do I manage this non-linear kind of the data into the linear approach. Okay, so this is something we have seen RBF. Okay, radial basis function, and as well as polynomial, and then sigmoid. Okay, all these kind of the conventions we have observed. So I'll come up with some other algorithm in the next week, guys, because the interest is here beyond the coding. What mathematical things we need to observe and all those kind of the conventions related to these kind of the usage, Navier, KNN. We have completed fourth one actually. So KNN we have done, Navier we have done. Last week we have seen decision trees. Now we are doing the support vector mission. Okay, thank you. Any doubts?
Thank you, Dr. Pawan. No.
Yeah. Thank you. Bye. See you back.